Imagine you're looking up at the sky on a clear night, and you see all those beautiful stars twinkling up there. Well, one of them is Betelgeuse, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Betelgeuse as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Betelgeuse is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our sun. Can you imagine that? It's so enormous that if we could somehow replace our sun with Betelgeuse, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Betelgeuse, we're actually looking back in time. Yep, you heard it right. Betelgeuse is about 600 light years away from us, so the light we see today actually left the star 600 years ago. It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Betelgeuse in the sky, and it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide-and-seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Betelgeuse is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Betelgeuse, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink. But just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-boggling levels, and this celestial tantrum triggers a colossal bang. So you can see why observing Betelgeuse is like having a front-row seat to the spectacular drama. But here's the big question. When will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Betelgeuse is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Betelgeuse will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us, tiny humans. But in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Betelgeuse could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Betelgeuse does go kaboom, what will happen? Well, get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Betelgeuse's supernova is going to be extra special. It's like the superstar of supernovas. It will shine so brightly that it might even outshine the other stars in the sky. Picture that, Betelgeuse stealing the spotlight. The show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that, 2 moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shock waves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder, saying, "Hey, look at this amazing spectacle. How dangerous will it be for us?" Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious. But, of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But, in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Betelgeuse status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Betelgeuse Brightness Monitor. By participating, you help scientists keep tabs on how bright Betelgeuse is shining. Your contribution can make a real difference. So join the monitoring team. You'll be part of something amazing, and who knows, your observations might even help predict when Betelgeuse will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Betelgeuse's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first. And of course, prepare in case it decides to mess with our climate. Stock up on essentials, like warm clothes and supplies, just in case we experience a mini ice age. But let's just hope it won't happen. So keep your eyes on the night sky, my friends. Betelgeuse may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars. And remember, there's always something extraordinary happening in the vastness of space.
All the stars we see, including our sun, are in a balance of powers. Stars are very heavy objects, so they have strong gravity, which presses them from the outside and makes them shrink. But inside a star, while it burns fuel, there are nuclear reactions that produce incredible amounts of energy. This energy is the light and heat that we feel during the day. But most importantly, these reactions increase the pressure inside the star and create a force that is fighting with gravity. So as long as the star has a full tank, it's safe. But then, the fuel runs out, the pressure inside the star falls, and the gravity wins. A star the size of our sun can shine for about 10 billion years. Specifically, our lovely sun is about 4.5 billion years old and has already burned half its fuel. The next stage in a star's life comes when it runs out of juice. Internal pressure drops, but gravity continues to press. At some point, a star simply collapses under its own weight and shrinks to the size of its core at the speed of almost a quarter of the speed of light. In less than half a second, a huge star turns into a small and dense object. This rapid collapse creates incredible shock waves that cause the upper layers of the star to explode. Now, an incredible amount of energy and matter is thrown into outer space. At this moment, luminosity of the star increases millions or even billions of times. This is the flash that our scientists can see with super powerful telescopes. But the light from this explosion doesn't reach our planet until many years later, so in fact, this star has long since faded. There are several options at this point. It all depends on the size of the star. If its mass is small, about the mass of our Sun, then for several months, this flash will become brighter and brighter until it reaches its peak. Then, the energy of the explosion will begin to dissipate, gradually fading and cooling down. A few years will pass, and the temperature of the former star will match that of space, and it will simply cease to exist. But the heavier the star, the more interesting the events will be. Heavy stars burn their fuel too quickly and have a much shorter lifespan. Stars weighing about 8 masses of the Sun can collapse into a rather unusual object, which is rarely found in the universe, a neutron star. This dull ball is only 6 to 12 miles wide and covered with a hard metal crust about half a mile thick. Neutron stars can weigh about 2 suns and have a strong gravity force. If you feel comfortable and in good shape on Earth, you wouldn't even be able to lift a needle or a match here. What's more, you would be pressed to the surface like a pancake and just unable to move. But there are stars dozens of times heavier than the Sun. An explosion of such a supernova, which weighs at least 40 times more than the Sun, gives birth to the most inexplicable and mysterious object in the universe, a black hole. At first, an incredibly bright explosion occurs. A shockwave spreads, carrying dust and matter of the former star around like a fog. And at the place of the explosion, only a small black disk is left. This black abyss is the heaviest object in the universe. It's so heavy that its gravity curves space-time around it. Yes, the closer you are to a black hole, the slower time will go for you. If you could get close enough to one of them, spend a couple of minutes in its orbit, and return to Earth, you would simply not recognize your home. 1 minute near a black hole can be a month, a year, or a decade on Earth. This depends on how heavy the black hole is. But don't get too close. The force of its gravity is so strong that even light can't escape from it. Humanity also knows about the existence of supermassive black holes. They gradually build up their mass, feeding on different cosmic objects just like a predator. Usually, such supermassive black holes lie in the centers of galaxies, and their gravity is so strong they can hold countless stars near them. For example, this is the only photo of a black hole, which is located in the center of the Messier 87 galaxy. The orange glow around it is its event horizon. That's the remains of the light from the objects this black hole has swallowed. You're quite safe though. The closest black hole is 1,120 light-years away. But supernovae can explode not only when gravity wins the fight with the star's internal forces. Sometimes the opposite happens. The nuclear fusion inside the star begins to affect much more matter than normal. The pressure inside a star increases, and it defeats the force of gravity that exerts pressure on the star from outside. At this point, there's a boom! This never happens by itself, and this type of supernova is only possible in binary star systems. 2 stars are spinning around each other. One star begins to swallow the substance from the other. Then, the nuclear reactions inside it are no longer in balance, and a supernova explodes. For some time, scientists believed that such an explosion could occur in 2022. There's such a binary system in the Swan constellation at a distance of 1,800 light-years from the Sun. The luminous red nova should have occurred here. Such a red flash would have been visible to the naked eye for months. And after the explosion itself and the merger of two stars, a new, hotter, and heavier star was to appear in their place. But a new analysis of the data revealed a calculation error, and this event will not happen soon after all. So now we see that a supernova explosion is a very dangerous event, and it can cause great harm to our planet if it happens close enough. The main danger is gamma rays. This is the radiation that comes from the explosion. When these rays reach the Earth, they affect our space shield, the atmosphere. They reduce the ozone layer and make us vulnerable to solar radiation and cosmic rays. In this case, all life on the planet is in incredible danger. And the bad news is that such an explosion could happen quite soon. Betelgeuse, the brightest star in the night sky, about 17 times larger than the Sun and 8.5 billion years old. It's begun to exhaust its fuel reserves. Scientists predict that this giant will explode like a supernova at any moment within the next 10,000 years. So it may happen in a few centuries or even tomorrow. Everything will happen as follows. Betelgeuse will collapse in a fraction of a second, and then it will explode so brightly that it will look like a second moon in the night sky. We will observe a new bright spot in the sky for weeks or even months. But then it will begin to fade until it completely disappears. Not without a trace though. In its place, there will be a neutron star weighing 1.5 times the Sun. It will be one of the biggest events that humanity has ever seen. Still, we have nothing to be afraid of. Betelgeuse is about 550 light-years away from us, so its X-rays and ultraviolet light will not affect us. A much greater danger is posed by the release of material that occurs in a supernova explosion. But this shouldn't make you worried either. The shockwave won't reach the Earth until 6 million years later, and it will be suppressed by the oncoming solar wind. So if we see Betelgeuse explode today, it will be an epic sight. But in fact, the star will not exist at the time, because it will mean the event itself happened almost 6 centuries ago. It's just that now the light from it has reached us. Some scientists believe that the Ordovician Silurian extinction events, which occurred almost 500 million years ago, happened exactly because of a star explosion. Then, almost 60% of marine vertebrates went extinct. Yet, it was not a supernova, but a hypernova. That is what scientists call explosions of stars 100 to 150 times larger than the Sun. In addition to the abnormal weight, the star must rotate very quickly. Such objects are very rare. In our galaxy, there are few of them, and scientists believe that hypernovae occur about once in 200 million years.
Betelgeuse, one of the biggest and brightest stars we've ever seen. It's both gorgeous and dangerous in a way you can't even imagine. This star is old, bloated, and unstable, like me. It can go supernova at any moment. And it hides a mystery our astronomers haven't managed to crack yet. Will it impact the future of our planet? Well, let's see. Betelgeuse is the bright red shoulder of Orion, the hunter in the sky. It's a red supergiant star, and by supergiant, I mean really giant. This star weighs somewhere between 15 and 20 suns, but it's so stretched out that if you dropped it in our solar system, it would reach all the way to Mars. Imagine our planet swallowed by a glowing, bloated ball of reddish fire. No thanks. As for the whole red giant thing, it means a star near the end of its life. When it runs out of hydrogen in its core, it starts burning hydrogen in a shell around it. This makes the star's outer layers puff up and cool down, so it looks much bigger, cooler, and red in color. Betelgeuse isn't exactly in peak health. Massive stars like this live fast and pass away while still young. Their lifetime depend on a lot of factors: mass, spin, how much metal they've cooked up in their cores. But even on the generous side, they only last a few million years. On the tight side, maybe a few 100,000. For comparison, our 4.6 billion-year-old Sun has plenty of life left. And tiny red dwarfs can keep going for trillions of years. Trillions! The universe itself isn't even old enough for red dwarfs to start kicking the bucket. Betelgeuse has already burned through all of its hydrogen, and now it's running on helium. That's what made it swell up into a red giant in the first place. Back in 2019, the star suddenly dimmed so much it looked like it was about to explode. Astronomers around the world were super excited. They thought we were about to witness a supernova in real time. But the truth was far less dramatic. Betelgeuse didn't reach the end of its cosmic life. It had just coughed up giant clouds of dust and gas, which drifted in front of it and blocked the light. Later, astronomers seemed to figure out the reason for this thing. The star basically blew off a huge chunk of its own atmosphere into space. And it was massive. The chunk had several times the mass of our Moon, and that's about 400 billion times more material than our Sun throws out in one of its normal eruptions. Once that piece cooled down, it turned into a giant dust cloud. From Earth, that cloud blocked a lot of Betelgeuse's light, making it look like the star was fading. But that's not all. Betelgeuse usually has a steady rhythm. It gets brighter and dimmer every 400 days, almost like a heartbeat. After this outburst, that cycle seems to have stopped, or at least gone quiet for now. When a star is old and unstable, its life might become pure chaos. One moment it's burning hydrogen, the next helium. Sometimes it shuts down. The next day it roars back to life. Its outer layers are so stretched out that they almost seem to be independent and have a mind of their own. Plus, there are terrible secrets these stars can hide, and Betelgeuse has one of its own. For decades, astronomers suspected Betelgeuse might have a hidden companion star, but spotting it was nearly impossible. Why? Because Betelgeuse shines up to 14,000 times brighter than our Sun. Its glow basically drowns out anything nearby. On top of that, our planet's thick atmosphere makes stargazing tricky. Light from space gets blurred and distorted as it fights its way through the air. When the Great Dimming happened in 2019, the Hubble Space Telescope was able to watch it unfold from above the Earth's atmosphere. It managed to clear up fears that Betelgeuse was about to explode, but even Hubble couldn't see through the massive cloud of gas and dust the star had coughed out to check for a potential companion. That's when astrophysicist Steve Howell from NASA's Ames Research Center tried a different approach. He turned to the Gemini North Telescope on Mauna Kea in Hawaii. It's a massive ground-based observatory with a wide opening that lets in more light. Gemini's secret weapon is a high-resolution camera called the Alopeiki Speckle Imager. Instead of taking one long exposure shot, it fires off thousands of ultra-short ones. It helps freeze the chaos caused by Earth's atmosphere. Later, computers stitch all those snapshots together, scrubbing away the turbulence and leaving behind crystal-clear images. So, Steve Howell and his team got down to work, convinced something had to be there. Something that had slipped through all the earlier searches. With the Alopeiki camera, they finally had the tool sharp enough to catch it, if it really existed. Howell later admitted the odds were slim. And still, Howell's team finally caught what looks like a faint companion star hiding at the far edge of Betelgeuse's atmosphere. And the best part was that it showed up exactly where earlier astronomers had predicted it might be. Same spot, same distance, in even the same angle. It wasn't just a random flicker of light, it matched the map. Right now, the companion is still hiding too close to Betelgeuse's blinding glare to see clearly, but its orbit will eventually carry it farther out, away from the giant star's brightness. That moment will come in November 2027, and when it does, telescopes should finally get a clean look. Those follow-up observations will settle the question for good. Is this faint little star real, or just a data glitch? Oh, by the way, the companion star already has a name. Betelgeuse comes from Arabic and means the hand of Al-Jaza, a legendary figure drawn across the night sky by ancient stargazers. They saw her whole form – hands, feet, head, hair – all stitched together by the stars of Orion. So Howell thought it only fitting to continue the theme. He named the companion Sawara, which translates to her bracelet. One day, long into the future, Betelgeuse and Sawara will spiral together and merge. But with a companion star or not, Betelgeuse is old, tired, and basically running out of gas. The clock is ticking, and one day, sooner or later, it'll go supernova. And when it does, it'll be a cosmic fireworks show unlike anything we've ever seen. Based on what we know, its size, how fast it spins, the group of stars it was born with, and the metals in its atmosphere, astronomers guess that Betelgeuse could explode as a supernova in a few 100,000 years. But don't get too comfortable, it could happen tomorrow. Or maybe it already did. Remember, the star is 500 light-years away. That means the light we're seeing now left Betelgeuse many, many years ago. If it exploded a century ago, we wouldn't know it yet. The star might already be gone. But when we finally see it go supernova, it'll be a show like nothing else in human history. A supernova can outshine entire galaxies, and at this distance, Betelgeuse will be blinding. It could be visible even during the day, brighter than any planet and nearly as bright as the full moon. But unlike the full moon, it won't be a comfortable glowing disk. Betelgeuse will remain a tiny pinpoint in the sky, but staring at it might actually hurt your eyes. This brilliance will last for a few months before fading, as all supernovae do. And don't worry, it won't hurt us. Why? Well, as crazy as a supernova is, stars are really far apart. That's where the inverse square law comes in. The energy a star or supernova emits spreads out over space. Double the distance, and the energy per spot drops to a quarter. 10 times the distance, and you're only getting 1/100th of the energy. It's the same reason you can walk a few steps back from a campfire and go from roasting to freezing in seconds. Anyway, what happens next is out of our hands. Maybe Betelgeuse will keep wobbling along for thousands of years, or maybe tomorrow night it'll light up the sky like never before. Either way, the universe has a way of surprising us, and the future will show what this giant star has in store. So this year, before September, a star in the constellation of Coronae Borealis will explode, and in the northern hemisphere, we'll be able to see it with the unaided eye. This star is T Coronae Borealis, a white dwarf star 3,000 light-years away from our solar system. It will turn into a nova, which we'll discuss a bit later, in spring or summer. Even though this occurrence is predictable, happening every 80 years, it's still a once-in-a-lifetime event, if you're human. T Coronae Borealis is not your regular star. It's actually a binary, two stars orbiting each other. This pair, though, is incredibly special. Occasionally, the stars increase their brightness to such an extent that they become visible on Earth. The white dwarf star is the more massive one of the two. But the most shocking thing about it is that it might pack the same mass as the Sun into a volume only as large as Earth. The companion star, an aging red giant, has already expanded so much that it's dumping its material onto the white dwarf. So it's time for another explosion for these two. It's going to take the star's brightness from magnitude 11 to magnitude 2. You see, in astronomy, magnitude is used to measure the brightness of a star or another celestial object. The brighter it is, the lower the number assigned as a magnitude is. Just like golf, low scores, you know. In our case, it means that we'll be able to see the star with the unaided eye, even in light-polluted skies. Now, we can only see the binary with binoculars in a completely dark sky. After the outburst, T Coronae Borealis will remain the brightest star in the constellation of Coronae Borealis for a few days before gradually dimming. Now, this event shouldn't be confused with a supernova. In a supernova, a star's core collapses, which leads to its complete destruction. It can only happen to a star 8 times the mass of the Sun. Instead of disappearing in a blinding flash of light forever, T Coronae Borealis will experience a nova, an explosion on its surface, flinging matter into space but not ruining the star itself. Such recurrent novas happen at regular intervals. T Coronae Borealis was known to astronomers from the past as the Blaze Star. Last time it exploded in 1866 and 1946. Astronomers from NASA believe it's going to do it again before September this year. The constellation of Coronae Borealis, also known as the Northern Crown, is one of the most beautiful out there. It's a curved semicircle of 7 stars, which is easy to find in April. You should go outside 2 hours after dark and look to the east-northeast. Once you find the Big Dipper, use the curve of its handle to go to Arcturus, finding the bright star in the Buddhist constellation due east. If you go diagonally down to the east-northeast horizon, you'll spot Coronae Borealis. Now, if you want to observe the brightening of T Coronae Borealis, it might be better if you get acquainted with the region and the stars of the constellation it's in. Once the event begins, you'll be able to compare its brightness against the other stars and observe the thing without using any fancy cameras. Now, a nova is a short-lived sudden explosion, involving a compact star as large as Earth or a bit bigger. The outburst comes from a white dwarf circling remarkably close to a regular star, so close that a stream of gas flows between them. This gas starts piling up until it creates a layer on the white dwarf's surface, and then it reaches a point where it detonates in a runaway thermonuclear explosion. According to astronomers, around 50 novae happen every year in our galaxy, but not all of them are noticed. NASA's Fermi Gamma Ray Space Telescope has observed several novae that occurred not far on the scale of the universe. They found out that each blast produces gamma rays. Those are the most energetic forms of light. Researchers also think that these gamma rays result from collisions among numerous shock waves, racing from the explosion site in a quickly expanding shell of debris. Now, after we've talked about novae, it's time to discuss something much more dramatic: supernovae. It's the largest explosion humans have ever seen. Each blast is a super powerful burst of a star. One kind of supernova is caused by the last hurrah of an extinguishing massive star. It happens to stars at least 5 times the mass of our Sun. Once they near the end of their lives, they go out with a ginormous bang. Huge stars burn incredible amounts of nuclear fuel at their core, producing tons of energy. It makes their centers immensely hot. Heat generates pressure, and this pressure keeps such stars from collapsing. But any star is in balance between 2 opposite forces. Its gravity attempts to squeeze the star into a teeny tiny ball, and the nuclear fuel burning at the core of the star produces powerful outward pressure. Now, when a giant star is running out of fuel, it starts cooling off. Its pressure drops, and gravity wins. The star collapses. An enormous object that is millions of times the mass of Earth collapses within 15 seconds. No wonder this brisk process produces enormous shock waves. It makes the outer layers of the star explode. Eventually, an incredibly dense core is all that is left behind, besides a growing cloud of hot gas called a nebula. A black hole, the densest object in the universe, is the result of a supernova of a star around 10 times as massive as our Sun. Also, there's another type of supernova. It usually happens in systems where 2 stars orbit each other, and at least one of these stars is a white dwarf the size of our planet. If such a star collides with another, or pulls too much matter from its neighbor, it can explode into a supernova. Also, supernovae are often so bright they can outshine the combined light of entire galaxies for several days or even months. Supernovae aren't common. Astronomers think just a few of them occur within the century in galaxies like our home Milky Way. But since the universe contains an enormous number of galaxies, we can observe a few hundred supernovae every year outside our galaxy. Unfortunately, space dust blocks our view of most supernovae happening within the Milky Way. Betelgeuse, a late-stage red giant, exploded in 2019, but it wasn't the event we expected to see. This star is found in the constellation of Orion and is huge, so big that if we moved it to the center of our solar system, its outer edge would go way beyond the orbit of Jupiter. When Betelgeuse eventually nears its end, it will explode in a stunningly bright supernova visible on Earth even during the day. This explosion could happen as soon as tomorrow or as far-flung as hundreds of thousands of years from now, so don't hold your breath. But then, what was it in 2019? Astronomers noticed that the star was dimming. They decided it was the initial stages of the grand show. But instead, Betelgeuse went back to normal over the course of the next few months. Further analysis revealed that the star hadn't dimmed. It just looked like that because we had been observing it through a cloud of stellar debris. At the same time, the amount of light in the photosphere of Betelgeuse ramped up. It was like a massive explosion of material from the surface of the star. Events like this occur on the Sun all the time, especially when our star's activity is high. Bits of the Sun's surface get tangled up and cast off. That's what we call coronal mass ejections. They don't harm our planet, but they can mess with satellites and electrical equipment. Now, getting back to Betelgeuse, we've never seen such a huge mass ejection on the surface of a star before. It's a new phenomenon which we can observe directly and even see surface details with the help of the Hubble telescope. Astronomers say we're watching stellar evolution as it happens for the first time.
Most of those twinkling dots scattered across the night sky seem unreachable. But one of them is Betelgeuse, a star so enormous and nearby that you can see it with the naked eye. To find it, locate the first 3 big dots in the Orion's belt. A reddish star to the left is Betelgeuse. It's one of the brightest stars we can see from Earth. And it's just 640 light-years away. No big deal. Betelgeuse has a blue-white O-type star, which is one of the hottest types to exist. Betelgeuse was scorching hot, reaching temperatures of about 90,000 degrees Fahrenheit. Although that was back in the day, now it's an elderly star and it cooled down to just 5,800 degrees. You know, vacation weather. Blue-white stars are absolutely massive and burn incredibly bright because they have loads of hydrogen fuel. But they have a price to pay for this glory. They burn through their fuel super quickly. As they age, they transform into red giants. This is exactly what happened to Betelgeuse. It burned through its hydrogen and started burning helium instead. This caused its outer layers to puff up like a balloon, turning it into a red supergiant and making it one of the largest stars out there. Now it's stretching over 700 million miles in diameter. Now it's about 1,000 times bigger than our Sun. If Betelgeuse replaced it, it would swallow up Mercury, Venus, Earth, Mars, even Jupiter. And its atmosphere would almost reach Saturn. But something strange has been going on. Betelgeuse spinning way faster than it should for a star of its size. Huge stars like Betelgeuse are expected to rotate slowly, but it suddenly started spinning at a rate of about 3 miles per second. Thanks to powerful radio telescopes, Betelgeuse's orange-red surface can be seen in detail. That's how we learned that it often changes its brightness. Sometimes Betelgeuse shines super brightly and then gets very dim. This happens about every 400 days. And recently, a telescope called ALMA, which is made up of many antennas working together as one, showed that Betelgeuse's surface seems to be moving unevenly. It's like one side is coming towards us while the other is moving away. But all of it might be a trick of light. Betelgeuse isn't as smooth as our Sun. Instead, it's super chunky. Its surface is like a boiling cauldron. It's bubbling and churning incredibly fiercely. Imagine giant plumes of hot gas erupting from its core, reaching the surface and then vanishing back inside. And these bubbles are bigger not only than the Sun, but Earth's entire orbit around the Sun. These bubbles also rise and fall super quickly, even faster than a spacecraft. And maybe this tricks our telescopes into seeing it spin faster than it really does. Some astronomers also think that Betelgeuse could have swallowed up another star, and this gave it a spin boost. But these are all just theories. Things got even more complicated when Betelgeuse dimmed once again, this time in a pretty unexpected way. What's interesting, it was discovered using a weather satellite. A regular telescope had a hard time seeing Betelgeuse clearly because of Earth's atmosphere. So they used a satellite that normally watches Earth's weather, but can also take pictures of space. As we mentioned, it usually brightens and dims about every 400 days. But recently, it suddenly dimmed by 2.5 times more than ever before. This event got the name the Great Dimming. The first theory said that Betelgeuse cooled down and sneezed out a bunch of material, creating a massive dust cloud. This cloud blocked the view of the star, making it look much fainter than usual. They also noticed something strange happening to that dust. It started behaving differently, which might be a sign that something deep inside the star was causing trouble. Betelgeuse's brightening and dimming cycle now happens faster in just 200 days instead of 400. And to add to the mystery, in the spring of 2023, it started shining even brighter than it normally does at its peak. Why is this frightening? Because Betelgeuse might be preparing for its grand finale, and this wouldn't be very good for Earth. We might be on the verge of a supernova. When massive stars like Betelgeuse run out of fuel in their cores, they start burning different elements like carbon, oxygen, and silicon. Eventually, they end up with iron in their cores. At that moment, everything changes. Adding helium to iron doesn't produce energy like other reactions do. Instead, it sucks up energy. This causes the star's core to collapse, leading to what's called a core collapse supernova. A spectacular, breathtaking show. Supernovas are so bright that they can outshine entire galaxies. But a Betelgeuse supernova would be special. Because it's relatively close to us, it would be so bright that we could see it even during the day. When it happens, Betelgeuse will shine as brightly as a full moon, but all that light will be concentrated in one point. For about 2 months, it will be so bright that you could read a book just from the light of the supernova, even if you turned off all the city lights and had a clear sky. The idea of witnessing Betelgeuse explode as a supernova is truly thrilling. After all, the last time a star went supernova in our galaxy was way back in the time of Johannes Kepler, more than 4 centuries ago. That event, known as the SN 1604 or Kepler supernova, dazzled the sky for weeks. But don't get too excited yet. We're not sure when exactly it'll happen. One study says that the star might be in its carbon-burning phase. If we're near the end of that stage, then Betelgeuse might blow up very soon, during the next tens of years. But it's nearly impossible to determine because during that last phase, the star barely changes at all. Even though Betelgeuse is close enough for us to study its surface, we can't peek inside its core to see what's really happening with it. We might as well be at the beginning of the carbon-burning phase, and in that case, we might have to wait 1,000 more years before that cool supernova. Another study says that Betelgeuse might have less than 300 years of fuel left in its core. They say that Betelgeuse is known to expand and contract regularly, and its pulsation pattern hints that Betelgeuse is much larger than we previously thought. This would suggest that the star is further along in its life cycle and closer to going supernova. Other guesses come from observations of similar stars. For example, a star called VYCMA in our galaxy is thought to be closer to going supernova than Betelgeuse, and it's been dimming steadily over the past century. unlike the relatively stable Betelgeuse. If Betelgeuse was about to go supernova, it would dim steadily and very quickly. Also, historical records suggest that about 2,000 years ago, people saw Betelgeuse as yellow, not red. If that's the case, then we might be in its early last days after all. In other words, we have no idea whether it will go supernova tomorrow or in 1,000 years. We just gotta wait and see. But let's say it goes supernova tomorrow. What happens to us then? The 1987 supernova in the Large Magellanic Cloud showed that the effects from the supernova might be so strong we can sense it even from very far distances. The Large Magellanic Cloud is almost 170,000 light-years away, and we still detected the radiation. It's kinda hard to say exactly what the danger zone is. A rough estimate could be around 100 light-years. Luckily, Betelgeuse won't pose any danger to humans. It's hundreds of light-years away, and its supernova won't influence us in any way. We'll be able to enjoy its supernova beauty without any harm.
Now see here, astronomers have recently discovered a neutron star, also known as a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe. And it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. They form from the remnants of massive stars that are at least 8 times the mass of the Sun. When such stars exhaust their nuclear fuel, they can no longer counteract the force of gravity pulling their matter inward. This leads to the collapse of their cores, triggering a massive supernova explosion that blows away the outer layers of the star. What's left behind is an ultra-dense core. That's a neutron star. These stellar remnants are incredibly small, typically just 12 miles wide. At the same time, they pack in more mass than the Sun. The density of neutron stars is also overwhelming. Imagine taking the mass of 2 suns and squeezing it into a sphere about the size of a city. A single teaspoon of neutron star material would weigh around 10 million tons. That's the same as the combined weight of 85,000 blue whales. Such an extraordinary density is what gives neutron stars their immensely powerful gravitational fields. When matter falls onto a neutron star, it accelerates to speeds of millions of miles per hour before slamming into the surface. The energy release from such impacts is truly astonishing. Now, despite its name, inside a neutron star, there are not only neutrons. A few protons survive down there too. Now, normally, protons repel each other since they have the same positive charge. But in a neutron star, that crushing gravity forces them so close together that the strong nuclear force takes over. It pulls them toward the neutrons like they're all part of the same team. Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like a neutron gnagi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going any deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penny pasta. So inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and penny pasta. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system located in a dense star cluster. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second, but a minute, it'll be over 42,000 revolutions per minute. At the same time, the newbie ties with another neutron star, which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait, we can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast, too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system, with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. So, you might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. No, accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star's surface, eventually. It triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than our Sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and thus confirmed its extreme rotational speed. But wait, the best part is coming. While neutron stars are already extreme, there's another class of them that takes things to a whole new level – magnetars. Now, magnetars are neutron stars with unimaginably strong magnetic fields, up to 1,000 trillion times stronger than Earth's magnetic field. These fields set them apart from other neutron stars. They can distort atoms in nearby objects, making life impossible anywhere near them. As for the energy density of a magnetar's magnetic field, it's so high that it's 10,000 times greater than the mass density of lead. Magnetars also produce bursts of X-rays and gamma rays that are so powerful they can temporarily outshine entire galaxies. These bursts are often triggered by star quakes, violent shifts in the magnetar's crust caused by their own magnetic fields. For example, a gamma-ray burst from a magnetar in 2004 was so strong that it disrupted Earth's ionosphere. It hit Earth, and it was so intense that several satellites picked it up. The SWIFT satellite, built specifically to detect gamma-ray bursts from across the universe, didn't just detect the blast. It got hit with so much energy that its sensors got completely overloaded. And SWIFT wasn't even facing the burst. The energy was so strong it passed through the spacecraft and still overwhelmed its cameras. If a magnetar was located as close to Earth as the Moon, its magnetic field would erase all credit card data on the planet by wiping the magnetic stripes clean. Whoa, that's the level of power we're dealing with here. Magnetars are extremely active, but for a relatively short time. Their intense magnetic fields decay after about 10,000 years. After that, they stop emitting strong X-rays and gamma rays. Astronomers think that there are at least 30 million inactive magnetars in the Milky Way galaxy alone. These silent cosmic relics are scattered all over the galaxy. Neutron stars and magnetars serve as laboratories for extreme physics. They allow astronomers to have insights into the behavior of certain matter under conditions you can never replicate on Earth. The incredible density of these objects helps scientists figure out what happens when protons and electrons get compressed together to form neutrons. This creates states of matter that don't exist anywhere else in the universe. These violent explosions on neutron stars and magnetars also play a critical role in the formation of heavy elements like gold and platinum. These elements get scattered all over the universe during these energetic events, eventually becoming parts of planets and stars and you and me. Oh, by the way, NASA's NICER instrument has played the key role in uncovering the mysteries of neutron stars. Its ability to detect X-rays with high precision allowed astronomers to study the rapid spin of the neutron star we've been talking about and the thermonuclear bursts that occur on its surface. So, what could be nicer than that? Now, I don't want to freak you out, but something bizarre has erupted in the depths of space. It was an explosion brighter than billions of suns. But the real mystery is that it doesn't match anything astronomers have ever seen. Usually, cosmic events like this follow familiar patterns, but not this one. It's a cosmic anomaly. This strange cosmic explosion has left astronomers totally baffled. It could be a super rare event where everything lines up just right, or it could be something completely new, never seen before. This event was first detected by an X-ray space telescope called the Einstein probe on April 8, 2024. It first appeared to be a regular gamma-ray burst. Those typically give off incredibly bright X-rays. But could the answer really be so simple? Something didn't add up. Now, gamma-ray bursts are the most powerful explosions in the universe, and they can happen in unusual ways. Long-duration gamma-ray bursts are caused by the demise of massive stars that spin incredibly quickly. When these stars run out of fuel, their cores collapse under gravity, forming an extremely dense object, like a black hole. At the same time, the outer layers of the star are blown away in a massive explosion called a supernova. Gamma-ray bursts are followed by jets. Those are twin beams of material shooting out from opposite sides of the collapsing object. They're super fast, moving at nearly the speed of light. These jets appear brighter if they're pointed directly at us. It's like how a flashlight beam is brightest when it's aimed straight at you rather than at an angle. Now back to our unusual cosmic explosion. Remember me telling you something wasn't adding up? Hey, it was just 45 seconds ago. Well, the problem was that when multiple telescopes observed this event in different wavelengths – ultraviolet, optical, near-infrared, radio, X-rays, gamma rays, you name it – it didn't match any known type of event. The most likely explanation, according to current research, is that this explosion is the result of a white dwarf star being torn apart by a medium-sized black hole. And still, it's not so simple. Now, black holes are areas in space where gravity is so strong that nothing, not even light, can escape. That's why they're called black holes. It's believed that stars with at least 3 times the mass of our Sun can collapse under their own gravity once they run out of their stellar fuel. When a star has so much mass packed into such a small space, its gravity becomes so powerful that it forces everything, including atoms, to squish together. This intense density leads to the formation of a black hole. So, when a white dwarf star is torn apart by a medium-sized black hole, it results in a high-speed jet of material that can be aimed directly at Earth. So, could this space disaster be the reason behind our mysterious event? Unfortunately, even though it ticks some boxes for several types of phenomena, including the one involving a white dwarf, it still doesn't fit all the criteria for any of them. The event's short duration and high luminosity are hard to explain using any scenarios we can produce. So, does it mean we have come across something completely new? The universe is full of energetic flashes caused by outbursts from stars and black holes, supernova explosions, stars being eaten by black holes, and other cosmic events. Astronomers usually figure out what these events are by analyzing their duration, frequency, source, and the specific combination of wavelengths they emit. Here, I just have to say a few words about the instrument that discovered the space anomaly. The Einstein probe is an X-ray space telescope project led by the Chinese Academy of Science in collaboration with the European Space Agency and the Max Planck Institute for Extraterrestrial Physics. That's a mouthful. This project is all about studying high-energy space events over time. Its main goal is to find inactive black holes and figure out how matter falls into them by spotting X-ray flares produced by these sudden space events. The Einstein probe also hopes to catch the electromagnetic signals from events that cause gravitational waves, like when neutron stars merge. It also keeps an eye on the whole sky to spot all kinds of space explosions and track already known changing X-ray sources. After the Einstein probe detected that ultra-bright space flash, the event was also observed by a few other ground-based and space telescopes, including the Nuclear Spectroscopic Telescope Array, SWIFT, Gemini, Keck, Dark Energy Camera, Very Large Array, Australia Telescope Compact Array, and Neutron Star Interior Composition Explorer. That's a bigger mouthful. Using all this data, astronomers pieced together the event's characteristics, but it didn't make the case any clearer. Quite the opposite. It just deepened the mystery. This event flared up in soft X-rays for the first 10 seconds, then plateaued at a steady glow for about 4 days before fading quickly within another day. This is much longer than typical gamma-ray bursts, which usually last from a few milliseconds to several hours. But it was still not long enough to fit into other known categories. The event's brightness in X-rays was also unusual. It was too bright for some types of phenomenon, but not bright enough for others. The most puzzling part is that the Very Large Array didn't detect any radio emission from the source when it was observed 11 days, 158 days, and 258 days after the initial flare. Now normally, when something this bright in X-rays lasts for this long, it's usually associated with a luminous radio counterpart. But in this case, no radio signals were detected, which is very strange and adds to the mystery. Astronomers didn't give up and considered several other possibilities, like fast blue optical transients. Those are a new class of explosions that release huge amounts of energy and blast matter into space at incredibly high speeds. These bursts are so powerful that one F-bot can be at least 10 times more powerful than a regular supernova. Fast blue optical transients do look like supernova explosions, but they are much faster. They flare up and fade away much more quickly than regular supernova. They're also much hotter, which makes the light seem bluer compared to other supernova. Since these explosions happen so quickly, it's tough to figure out what causes them. In January 2019, astronomers narrowed it down to 2 causes: a black hole consuming a white dwarf star, or a rare kind of supernova that leads to the formation of a neutron star or a black hole. Now, another explanation for our mysterious space explosion, and astronomers think it's the most likely one, is a tidal disruption event. It happens when a black hole swallows a star, causing a flash of light. When a star gets too close to a supermassive black hole, it doesn't get off easily. No, the black hole's powerful tidal forces tear the star apart, breaking it into pieces and pulling it toward the black hole. Its remains turn into a stream of debris that falls toward the black hole's accretion disk. However, before the debris settles into the disk, it overshoots the black hole in an elliptical path, only to be pulled back in. At one point in this path, the debris collides violently with other parts of the star being pulled in, and that's when we start to see the first bursts of emissions. In some rare cases, tidal disruption events create huge jets of material that shoot out from the black hole's poles. If these jets happen to point directly at Earth, we can see the signature of the event. It often looks like an intermediate mass black hole eating a white dwarf star. However, there should still be some radio emissions coming from the jet of a tidal disruption event. The reason none have been detected yet might be that the event was likely observed too early. Previous studies suggest that it can take hundreds or even thousands of days for the jet material to slow down enough to start sending out radio signals. If future observations pick up radio emissions, it could help solve the mystery. But if there are no signals, it might mean it's a very unusual gamma-ray burst or something completely new that we haven't seen before. Now, it's been a long time since there was a supernova in the Milky Way, over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the Southern Hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Coronae as the seventh brightest star in the constellation Coronae, Eta being the seventh letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century, but modern studies of Eta Coronae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Coronae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Coronae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Coronae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Coronae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Coronae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Coronae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either zero magnitude or negative magnitude. The full moon, for example, is magnitude negative 13. A magnitude positive 4.5 star, like Eta Coronae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Coronae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Coronae is really two stars, Eta Coronae A and Eta Coronae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Coronae C. Good guess. Blown out into two incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Coronae is, without a doubt, one of the strangest-looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Coronae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Coronae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Coronae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean two things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close. Because the eruption we saw in the year 2000 really happened 10,000 years before, many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about one full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in the star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful stellar neighborhood, except for those Martians next door.
Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those two stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries. This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass, or a GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of two stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how big or bright it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the two stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, researchers concluded that Polaris B is much older than its bigger sibling, but it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's North Pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once two stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities, since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories have been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis Earth spins around and extended it over 300 light-years past the North Pole, at the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole, but one day we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South poles won't always point towards the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars and back again. One day, the title of the North Star will go to Vega. It's the 5th brightest star in the night sky and the 2nd brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it'll regain this status in 12,000 years or so. This star is located a mere 25 light-years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old star system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a Lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 15-inch refractor, and it happened again in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are 2 areas, an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution. Astronomers detected something strange happening in the darkness of space. They picked up a series of bizarre, unexplained signals coming from distant stars in the Ursa Major constellation, and literally no one can explain their origin. Is it some unknown natural phenomenon or something far more mysterious, more artificial? Let's explore this latest space discovery, the science behind these signals from space, and what scientists believe might be sending them. So, scientists picked up 2 identical bursts of energy coming from deep space. They weren't random and they weren't background noise. They seemed to be precise and even kind of purposeful. The signals came from the constellation Ursa Major. It lies about 100 light-years away from our planet. The star emitting those signals is called HD 89389. It's a little bigger and brighter than our Sun, but nothing too unusual. That is, until 2023. That's when NASA scientist Richard Stanton noticed something he'd never seen before. The star suddenly flashed, getting bright, then dim, then bright again, and it happened in just a few seconds. There were two identical pulses, exactly 4.4 seconds apart. According to Stanton, the star's behavior was beyond strange. The changes in brightness were far too powerful to be dismissed as random noise or the result of turbulence in Earth's atmosphere. A star over 1 million miles wide doesn't simply fade in and out like that. For a star to just blink out like that in 1/10 of a second is not the kind of thing science can explain easily. But it got even more curious. And the more scientists looked, the stranger it got. Apparently, this wasn't just a flicker, it was deliberate. It looked like something made that light change. But what could it be? It was a truly deep space mystery. So for the next 2 months, Stanton worked a lot. 1,500 hours of total observation time, checking every possible explanation. He compared the data to lightning strikes, airplane reflections, meteors, and even software malfunctions. And every single time, the result was the same. Nothing matched. That's when the research team had to admit what no one expected. Apparently, they couldn't rule out the possibility that those pulses might be artificial. The thing is, after checking every possible explanation, Stanton realized that their space telescope discovery wasn't something anyone had seen before. It couldn't be explained as static, it wasn't lightning, and it definitely wasn't a passenger plane flying by. But it reminded him of something. You see, back in 2019, astronomers detected another strange double pulse. This one was coming from a hot gas giant called Dimidium, about 50 light-years away from Earth. At first, experts laughed it off and blamed it on birds flying through the telescope's field of view. But the new signal didn't seem like one of those simple mix-ups. So, Stanton kept digging. He looked at everything and concluded that a shockwave in Earth's atmosphere could explain the signals. But that idea didn't quite fit. For all 3 pulses to sync up that perfectly, the timing would have had to be almost impossible. The researchers also looked into other possibilities. Maybe the light was bent by some far-off object in our solar system. Maybe a satellite or asteroid partially blocked it. Or maybe it was caused by refraction or even gravitational waves. But none of those theories really made sense either. Some details were clearly missing for astrophysicists to explain how a star could blink that fast and that cleanly. For now, Stanton believes the only way forward is to study all 3 known events more closely and see which explanations still hold up. You're probably asking yourself, how was this astronomy discovery even made? It started more than 60 years ago. That's when scientists officially kicked off the search for life beyond Earth. They called it the Search for Extraterrestrial Intelligence, or SETI. The pioneer of this undertaking was something called Project Ozma. It was led by astronomer Frank Drake, the same guy who came up with the famous Drake equation. This equation is a way for scientists to make an educated guess about how many worlds in our galaxy might have intelligent life that can send out signals we could detect. The idea is simple. You start with how many stars are born in our galaxy. Then you figure out how many of those stars have planets and how many of those planets could support life. Then you gotta figure out how many of those worlds might actually have living things and how many of those might develop intelligent beings. And finally, you try to calculate how many of those might build technology that could let them communicate with other civilizations, like ours. Now, the equation isn't really meant to give a clear number. It's more like a big thought experiment that helps scientists consider all those different pieces needed for life to exist and be noticed in the universe. Anyway, back in 1960, Drake and his team pointed a giant 82-foot radio dish at 2 nearby stars, Epsilon Eridani and Tau Ceti, and listened for anything unusual. Between April and July of that year, the observatory in West Virginia stayed tuned in, waiting for a signal from the stars. Unfortunately, nothing came through. But the project became the starting point of everything that came after. Since then, scientists have carried out dozens of similar searches using all kinds of wavelengths and technologies to find signs of intelligent life. These days, we call them technosignatures. And while no one's found solid proof yet, there have been a few moments where even experts couldn't rule out the possibility that something, or someone, might be out there. That's where Dr. Richard Stanton comes in and makes the shocking space discovery. Stanton is a NASA scientist who worked on some of the most iconic missions like Voyager and Grace. The latter was a project by NASA and the German Space Agency, where two satellites flew around Earth together, side by side. By watching how the distance between them changed, scientists could see how Earth's gravity shifted in different places. That helped them learn about things like melting ice, ocean movement, underground water, and even climate change. But after retiring, Stanton took on a personal project, searching for intelligent life from his own Shea Meadow Observatory in Big Bear, California. Using a custom-built telescope and a photometer he designed himself, Stanton spent years scanning more than 1,300 sun-like stars, not for radio signals from space, but for flashes of light. Unlike traditional SETI studies that focus on radio waves, Stanton's approach, called optical SETI, looks for laser-like pulses, sharp, quick bursts of light that could be used for communication across the stars. This idea actually goes back to the early 1960s, when two scientists suggested that advanced civilizations might use incredibly powerful nanosecond laser pulses to send visible signals that could outshine their own stars. For this study, Stanton didn't scan huge portions of the sky. Instead, he focused on one star at a time. He was staring at it for an hour straight and recording its light at incredibly tiny intervals, just 100 microseconds apart. That's fast enough to catch flashes less than a blink of an eye. Then he analyzed the data, searching for any strange repeating patterns and unexplained signals. And eventually, his efforts paid off, and he made the very space discovery we talked about. A sun-like star about 100 light-years away in the constellation Ursa Major sent two fast, identical pulses of light. So far, these signals remain unexplained. No one knows for sure what caused those perfect twin pulses. We can't even figure out how far away the source really was. Was something passing in front of the star? Or was the light itself being changed by something we don't understand yet? What we do know is that something strange is happening out there in Ursa Major. Maybe it's a new kind of cosmic event. Or maybe it's something else entirely. And one day, we'll crack this deep space mystery.
So, stargazers were chasing the Perseid meteor shower, but instead, they got something more unusual and rare, a massive cosmic swirl in the sky. In August 2025, reports poured in from Maryland, New York, New Jersey, Illinois, Ohio, Nebraska, a total of at least 10 states, and Ontario, Canada. The ghostly spiral was floating over the highways, houses, and woods for almost 10 minutes before vanishing like a Penn and Teller trick. It bloomed, unfurled, and then just faded. The internet went nuts about the mysterious spiral. Witnesses snapped video with shaky hands, wondering what they just saw. And of course, theories bloom faster than wildflowers in spring. Some people thought it must have been a Perseid meteor. It all happened smack in the middle of the season for those shooting stars. But meteors blaze bright and fast, and this was slow, hypnotic, and weirdly beautiful. Then a rocket theory took hold. The United Launch Alliance's Vulcan from Florida was a prime suspect. But the geometry didn't add up, as that rocket headed east, not the Midwest. The timing and path just didn't align. Finally, the European dark horse entered the spotlight, Ariane 6. They launched this rocket with a weather satellite on it from French Guiana just minutes earlier. Some astronomers mentioned that it probably released frozen exhaust high in the atmosphere during its cleanup phase. That spinning fuel cloud could have caught the sunlight just right, creating a spiral that drifted in the upper atmosphere. People were able to see it for a good stretch before dissipation. What we do know is that the physics behind what we witnessed are normally part of the twilight phenomenon. As the upper stage of a rocket starts spinning in space, it dumps leftover fuel. In the upper atmosphere, that fuel instantly turns into ice crystals that scatter sunlight and form a spiral that looks like something spun straight out of a fantasy novel. It's totally natural and doesn't have to do with extraterrestrial civilizations like some people thought. Still, nothing's confirmed, but there are more similar glowing structures lately, mostly from SpaceX's Falcon 9 rockets. That's why they even have a nickname, SpaceX Spirals. In March 2025, a glowing swirl formed above Europe like a neon whirlpool, or the Milky Way got into a blender. The blue spiral stretched and spun steadily for about 8 to 12 minutes above the UK and further into Sweden, Poland, Hungary, and Croatia. The sponsor of this sky show was a Falcon 9 rocket that had launched from Cape Canaveral earlier that day. Once the rocket reached space, it dumped leftover fuel that froze into ice crystals, and people got to enjoy an amazing sight. Now, normally, SpaceX spirals come in a perfect vortex shape, but the one that appeared over Europe in 2024 had two faint, horn-like pillars of light. It's the only horn spiral we've seen so far. It photobombed the auroras over countries like Poland, Lithuania, and the Czech Republic. Earlier that evening, a Falcon 9 rocket launched from California's Vandenberg Air Force Base, carrying Earth-observing satellites. Another layer to the story is that there was a strong G3-level geomagnetic storm happening at the same time, thanks to a coronal mass ejection that crashed into Earth's magnetic field earlier that day. That storm pumped up the northern lights, which became the stage backdrop for the spiral's eerie entrance. Another SpaceX spiral example is from April 2023. Over Alaska, people who went out to watch the northern lights suddenly froze as a glowing blue spiral swirled into view. It was drifting across skies like someone had opened a portal to another dimension. Cameras caught it, social media went wild, and Stargate in the sky was suddenly trending. But as it turned out, the portal was no invitation from the Milky Way, but the aftermath of a SpaceX Falcon 9 rocket. Frozen exhaust spun in the upper atmosphere and reflected sunlight in a perfect corkscrew pattern, framed against shimmering auroras. The science was straightforward, but the sight was straight out of a science fiction film. Now, spirals aren't the only kind of weird atmospheric shows nature throws for us. In Italy in 2023, a massive red ring of light suddenly flashed high above a storm. Scientists identified it as an ELF, a type of transient luminous event. When a lightning bolt unleashes a powerful electromagnetic pulse, it slams into the ionosphere's nitrogen and creates a glowing red disk hundreds of miles across. The phenomenon lasted only milliseconds, but thanks to time-lapse cameras, it burned into memory like the outline of an extraterrestrial saucer. Normally, only satellites orbiting the Earth can spot ELVs, but in this case, the lightning bolt was at least 10 times more powerful than regular ones, so it was visible to humans on Earth. Another cool thing about it is that it looked like it was hanging in the sky, directly above the town of Posigno. But in reality, the massive halo appeared above central Italy and part of the Adriatic Sea. It was just a forced perspective that made it look like it was in a completely different space. You can only get the best view of some sky shows directly from space. Aboard the International Space Station, orbiting 250 miles above Earth, astronauts once reported seeing two mysterious blue blobs glowing beneath them. From orbit, they looked like deep-sea creatures that had been misplaced in the sky, two radiant orbs pulsing against the blackness of space. It turned out that one blob was a massive lightning strike somewhere in the Gulf of Thailand. You can't normally spot those from the ISS, as clouds hide them. But this one strike occurred next to a large circular gap in the top of the clouds, and the lightning illuminated the surrounding walls of the cloudy caldera-like structure. The second glowing blue blob was the Moon playing tricks with light. Because of where the Moon was lined up with the International Space Station, the sunlight it reflected had to pass through Earth's atmosphere before reaching the astronauts' cameras. And when light hit the atmosphere, things got funky. Tiny particles floating in our air, like dust, water, and other stuff, scattered light in different ways. Not all colors of light behave the same, though. Each color has a different wavelength. Blue light waves are the shortest of the bunch, which makes them the easiest to scatter in all directions. So, when moonlight passes through our atmosphere, the blue part of that light spreads out the most. That's why the Moon looked like a fuzzy blue blob with a halo instead of its usual white glow. It's the same reason the sky looks blue during the day. Sunlight hits our Earth's atmosphere, and the blue wavelengths scatter way more than the reds or yellows. Our eyes pick up that scattered blue light, and boom, blue sky. So, basically, the ISS astronauts weren't seeing a new phenomenon. They were seeing the same science that makes summer skies look so bright. Only this time, the Moon got the blue makeover. Then, residents of Newburyport, Massachusetts, saw a fire rainbow pop up out of nowhere on June 2, 2024. Now, technically, it's called a circumhorizontal arc, and it happens when sunlight hits ice crystals high in the clouds at just the right angle, bending into a slice of rainbow that looks like it's flaming across the sky. It's all about timing and angles. The sun needs to be over 58 degrees high, and you need cirrus clouds or jet contrails carrying ice crystals. Light passes through the crystals, splits, and suddenly, boom, a rainbow in the clouds, usually just peeking through gaps. It's not just Massachusetts. In Weatherford, Texas, on April 15, 2025, jellyfish clouds called virga did the same thing. Ice was falling but never hitting the ground, creating a floating rainbow halo. And on April 25, 2024, in Ohio, photographers caught the crystals scattering light into perfect rainbow colors again. So, next time you're outside, keep your eyes peeled. Mother Nature loves to show off, and sometimes she paints the sky on fire.
An ultra-powerful explosion happened just outside the Milky Way galaxy, kinda next door in cosmic terms, and it was unlike anything we've witnessed before. The thing kept blasting again and again, shooting out crazy strong bursts of energy called gamma rays. It was almost an entire day of non-stop firing back in July 2025. In gamma ray time, that's basically forever, because normally gamma ray bursts last from a few milliseconds to a few minutes, not hours on end. But the craziest thing is that this phenomenon might be linked to an elusive and mysterious kind of black hole, the existence of which we haven't proven yet. Scientists gave this phenomenon a complex sciencey name. Usually, these gamma ray bursts happen when a giant star goes off. One big dramatic exit, and that's it. But this space diva didn't get the memo and kept coming back for encores. NASA's Fermi telescope first spotted this bizarre space performance on July 2nd. But then some other space gear, the Einstein probe, realized it had already been blasting the day before. Scientists tossed around a few guesses. It could have been a massive star, like 40 times the size of our Sun, that went out in a special kind of way. Not your average star demise, but one that somehow kept its cosmic engine running, like a car that won't stop even after the gas runs out. Another theory is even wilder. Some scientists think those space fireworks might have gone off when a star, likely a tiny one called a white dwarf, got shredded by a black hole. It's like a cosmic blender moment. They call it a tidal disruption event, or TDE. You see, not every star goes out with a giant boom like in the movies. Most just get old, puff up, and slowly fade away, leaving behind their tired little cores. Those leftovers are called white dwarfs, star corpses made of super weird squished up gas. You see, what happens to a star when it goes off depends on how big it was when it was born. Stars that start out kind of small, about the same size as the Sun or up to 10 times bigger, usually end up as white dwarfs. Most of the time, these stars run out of fuel and blow off their outer layers, creating a glowing cloud called a planetary nebula. What's left behind is the super hot dense core, about the size of Earth. That's the white dwarf. They're still really hot when they form and slowly cool down over time. After billions of years, they might turn into cold, dark, black dwarfs. But the universe isn't old enough for any of those to exist yet. Anyway, let's get back to our investigation. If this second theory is right, the black hole responsible for this cosmic show wasn't a regular one. To pull off something like this, it would need to be a super rare kind of black hole. One of those mysterious intermediate mass black holes scientists have been trying to find forever. Before we move further, let's take a look at the black hole lineup. Small ones are called stellar mass black holes. They're formed when massive stars weighing somewhere between 20 to 100 suns collapse. Supermassive black holes are real space behemoths. They're millions and even billions of times heavier than the Sun. They chill at the centers of galaxies. Even our home Milky Way galaxy has one called Sagittarius A star. This black hole is mostly dormant. It absorbs gas or dust only occasionally, but its estimated mass is millions of times that of our Sun. There might be one more type of black hole: primordial black holes. Scientists think they might have formed in the very first moments after the birth of the universe. That's when pockets of hot material could be dense enough to form black holes. Their masses might have ranged from 100,000 times less than a paperclip to 100,000 times more than that of the Sun. After that, the universe expanded and cooled very fast, and the conditions for forming black holes this way came to an end. These days, 13.8 billion years later, astronomers still haven't found definitive proof that those primordial black holes even existed. On the other hand, it's possible that they could have evaporated as space became older, due to certain processes happening at the edges of their event horizons, aka the points of no return. According to theoretical predictions, lower mass black holes with less mass than a mountain could evaporate more quickly than larger ones. If this idea is correct, then many of those early black holes have already completely dissipated. But more massive primordial black holes could still be lingering across the universe. Anyway, if we get back to the already proven kinds of black holes, between stellar-sized black holes and supermassive ones, there are elusive intermediate mass black holes. Scientists think they exist, but they're like Bigfoot. Lots of theories, not much proof. Astronomers think that small black holes might crash into each other and merge over time to form those medium ones, but spotting one is almost impossible. They're sneaky and silent. People often tend to mistake them for star graveyards, clusters of smaller black holes just hanging out. Sometimes, intermediate mass black holes even hide behind groups of stars that orbit them real close. The best way to catch such a black hole is to look for clues. Scientists measure the mass of black holes when they crash into each other, or spot them mid-meal when they're munching on a nearby star. So far, around 300 possible intermediate mass black holes have been found, but no one is totally sure which ones are the real deal. And now, astronomers think they've finally caught this super rare missing link black hole. Right now, it might be snacking on a poor star way out at the edge of some distant galaxy. In a study published on April 11, 2025, scientists talk about a black hole called HLX-1. It's hanging out about 40,000 light-years from the center of its galaxy and roughly 450 million light-years away from us. Using data from NASA's Hubble Space Telescope and the Chandra X-ray Observatory, the team spotted a bright flash, that very tidal disruption event that occurs when a black hole tears a nearby star to pieces. Then they ran computer simulations to recreate the whole thing, and it showed HLX-1 stretching the poor star like space spaghetti. By the way, this process is indeed called spaghettification. Astronomers have their own cosmic jokes, you know? Anyway, scientists first spotted something weird going on with HLX-1 back in 2009. NASA's Chandra X-ray Observatory caught a super bright glow coming from deep space. Turns out, it could have been another tidal disruption event. The glow from HLX-1 hits its peak around 2012, and it's been fading ever since. But of course, there's a catch. Nobody's totally sure it's a real intermediate mass black hole. You see, that light might not be from a shredded star at all. It could be from an accretion disk, a giant, super hot ring of gas and dust swirling around the black hole's edges. And the only way to figure out what's really going on is to keep watching. If the light keeps fading and doesn't flare back up, then yeah, that poor star probably got eaten. Intermediate mass black holes are a big deal because they're the missing link in the black hole family tree. The connect the dots piece in understanding how black holes grow up. There's also an idea that intermediate mass black holes might start out as big stellar mass black holes and just keep bulking up over billions of years until they become those massive, city-sized monsters at galaxy centers. That means most of their lives, they're probably lurking way out on the galaxy's edge. Like HLX-1, before they get launched into deep space. And now, some scientists think there could be a sneaky intermediate mass black hole hanging out on the outskirts of our Milky Way right at this moment. Even if there isn't, the research team is still keeping an eye on what's happening after that blast and trying to piece together what in the universe actually caused it. Next up on their to-do list is figuring out exactly where it happened. Once they pin down the location, they'll be able to measure just how much cosmic energy this thing pumped out and how big the explosion really was.
Boom! It was an epic space explosion that made scientists' hair stand on end when they discovered it in February 2020. Its size and power are enormous, even by cosmic standards. We set our destination to a group of galaxies in the Giraffe constellation. If our rockets could fly at the speed of light, as fast as it takes the light from the bulb in your lamp to reach your eye when you switch it on, zoom, instant, it'd take 2.6 billion years to get where this explosion occurred in space. 2.6 billion years. A lot's happened in that time here on Earth. That long ago, dinosaurs weren't even around yet. Primordial life was just leaving the ocean and heading on land. Well, we're traveling faster than the speed of light, and we reach our destination, ground zero, for a boom so big, it'd be like 600 million suns exploding simultaneously. And our sun is massive to begin with. It could fit 1 million Earths inside. In fact, 99.8% of the stuff that makes up our entire solar system is the sun alone. The remaining 0.2% is all the planets, moons, asteroids, and other random cosmic bodies floating around our star. And here's the real kicker. This burst lasted 100 million years. That's from today's digital world with smartphones and self-driving cars, all the way back to dinosaur times. So what set off this space boom of epic proportions? A black hole. What else? This monster swallowed so much substance that it choked and shot out a bunch of plasma beams. They cut through space and formed a cosmic wasteland all around the site. It was thought to be the biggest explosion in the universe. But sooner or later, every record gets broken. We head to another galaxy cluster. This one, dubbed Ophiuchus. An explosion thundered in it 5 times more powerful than the one in the Giraffe. It was so big, you could easily line 15 Milky Ways across its blast area. Mind you, our galaxy is over 100,000 light-years across and home to 200 billion stars. Yeah, whoa is right. It was the largest space blast since the Big Bang that started it all 13.8 billion years ago. So what was the source of this blast? To answer that, we'll need a simple analogy. Just like on Earth, space sort of has its own megacities. These New Yorks and Tokyos of the cosmos are massive, and that word doesn't even do it justice, but I tried. They're officially called superclusters of galaxies. At the center of the most mega huge ones, you'll find a supermassive black hole. Now, scientists still don't know much about them, but the theory goes that they're essentially a whole bunch of stuff, or matter, that gets squeezed into a teeny tiny point that can't even be measured because it's infinitely small. Yeah, complicated stuff. Think of it this way. It'd be like taking the entire Earth and shrinking it down to the size of a grain of rice. That grain of rice would still weigh the same as the planet. All that stuff would just be really squished together. So more matter equals more gravity, meaning a black hole's pull is unescapably strong. Not even light can get past it, hence the whole black part of its name. Funny thing is, we can't even see them with our eyes. Black holes don't glow or reflect light. They just swallow it up like spaghetti. Oh, makes me hungry just thinking about it. But back to epic space things that go boom. A supermassive black hole exploded in this Ophiuchus supercluster of galaxies. This monster stopped pulling in everything around it like black holes usually do. Quite the opposite. It started spewing stuff out. A colossal stream of plasma ripped through space almost at the speed of light and broke through a bubble 1.5 million light years across. Every thousandth of a second, it was like 20 billion megatons of TNT went off, and it continued doing that for 240 million years. But now, I draw your attention to the heavyweight of the Milky Way. It's the toughest guy in the galaxy, a supermassive black hole called Sagittarius A*. The mass of this beast is 4 million times that of the Sun. And you'll like this, it's only 25,000 light years from our home planet. In space terms, this thing is pretty much like our neighbor 2 houses down the street. Wait, don't worry, no need to pack up and move. Our neighbor has given up his old business of shooting hot jets into space. But in 2019, he did make astronomers' hearts skip a beat. Near this Sagittarius A*, they noticed a flash that was 75 times higher than normal. Their theories: 1. The hole swallowed up part of a star that found itself wandering way too close for comfort. Or 2. A gas cloud crashed into it. After a 14-hour spike in activity, Sagittarius A* finally calmed down. Phew! But in the past, this giant was quick-tempered and knew how to light space up. 3.5 million years ago, our very ancient ancestors, as in they weren't technically human yet, were already walking across Africa, innocently unaware of a cataclysm happening far off in the sky above them. It looked like a beacon that suddenly turned on and shot out 2 cone-shaped beams. The whole thing was triggered by a hydrogen cloud 100,000 times more massive than the Sun. It came too close, and Sagittarius A* reacted. Those jets of plasma cut through space for 200,000 light years. They didn't stop for another 300,000 years. That's the snap of a finger on the cosmic scale, but astronomers still find traces of that boom even today. Neutron stars also know how to set off some fierce fireworks. They appear after giant stars run out of fuel and collapse in on themselves. Imagine the entire sun getting squished down into the size of a small city. Yep, that makes neutron stars incredibly dense and heavy. 1 teaspoon of their matter weighs around 10 million tons. They spin extremely fast, hundreds of full rotations a second. And for some of them, they shoot out energy beams from the poles, making it look like a cosmic lighthouse. One of the most interesting neutron stars is in the constellation Sagittarius. Like black holes, it has powerful gravity and pulls in tons of matter. This all collects in a massive rotating disk. This particular one was powered by hydrogen from a nearby star. It gulped up its neighbor, taking in so much matter that it started heating up. The result? A gigantic fireball launched from its surface. Astronomers witnessed this on August 20th, 2019. they saw a 20-second flash that lit up space. It was the brightest burst NASA has ever seen. The star spent more energy on it than the sun produces in over a week. But of course, nothing beats the biggest boom of them all, the one that brought life to our entire universe, according to the most popular theory. But first, a little backstory. Scientists say only 5% of the universe is stars, planets, asteroids, comets, dust clouds, you, me, your chinchilla, all life, basically all the stuff you can see with your own eyes. So what can the remaining 95% be? The mysterious and dubious sounding dark energy and dark matter. In simple terms, they're like the yin and yang of space. Dark matter makes things attract to each other with gravity. It's the glue of our universe, keeping everything together. Dark energy does the opposite. It makes things repel and grow further apart. So the theory goes. And weirdly enough, dark energy makes things grow further apart the farther they are from each other. Scientists can even see this for themselves. The more distant a galaxy is, the more quickly it's moving away from Earth. But those two forces weren't always around. In fact, about 13.8 billion years ago, there wasn't anything around. Everything was condensed into a teeny tiny dot that's infinitely small. Sound familiar? Yep, this mysterious, forever shrinking point is also in the center of black holes, and it's called a singularity. It's where all our fancy science and math breaks down. It's the most puzzling thing out there. But one day, that incredibly dense and hot point started to expand in all directions, and it grew faster than the speed of light, doubling its size 100 times within a fraction of a second. If you want the specifics, it was 100th of a billionth of a trillionth of a second. Yeah. The more time passed, the faster and bigger it grew, and it's been expanding since, like blowing up a balloon that never pops. Scientists called this expansion the Big Bang.